Lesson 7.5 is on systems of inequalities. So we're going to start off with sketching y is less than or equal to, that's our inequality, less than or equal to x squared plus 1. So let's do a quick xy table. And when x is 0, y is 1. When x is plus or minus 1, then y is 2. When x is plus or minus 3, we have y's, well, let me do plus or minus 2. Okay, when plus or minus 2, y is 5. So let's just plot those. 0, 1, 1, plus or minus 1, 2, and 2, 5. So this is obviously a parabola. And because the inequality is greater than or equal to, this is going to be a solid line. So let's plot a solid line. Okay, our parabola looks like that. Now, we want to use a test point to see which part of it is true. So we come to our original equation. And a good test point to always use is 0, 0. So we want to test 0, 0. Put it in the equation, so 0 for y less than or equal to with a question mark, less than 0 plus 1. The answer is true, so that's the part you shade. So we're going to shade everything below the parabolic line to indicate that is what satisfies the equation. Okay, example 2, we want to sketch the system of equations. We have x is greater than or equal to 3. So again, that's going to be a solid line. We can put that in. And then y is less than negative 1. So this needs to be a dotted line or a dashed line. So I'll just dash it. Okay, now the test points. We don't really have the same test points that we did in the first one. We just look at the first equation, x is greater than or equal to 3. So everything from this arrow going to the right is going to be true. And then on y is less than 1, anything less than 1, so we draw our arrow this way, makes it true. So anything that satisfies both of those conditions is going to be true. So you would shade this part right here. Okay, example 3, we have sketch x plus y is greater than a negative 2. So this is linear, and let's just do an xy table, assuming that we have an equal sign instead of a greater than sign. So when x is 0, y is negative 2. When x is negative 2, y is 0. So let's put in those points. So negative 2, 0, right here. 0, negative 2, right here. So now, because it's a inequality, we're going to do a sketched line, or a dashed line rather. And again, we need to find a test point. And so we'll use 0, 0 again and put it into the equation. So we have x, so we have 0 is x plus 0 for y is greater than, with a question mark, negative 2. So that's true, 0 is greater than negative 2. So we're going to sketch this side of the line. I said sketch, I meant shade the side of the line because our test point 0, 0 is in the true point. Okay, example 4, we want to sketch and label the vertices of a system of equations. So let's call this equation, this is equation 1, 2, and 3. So we want to sketch each one. So let's do 1, we're going to do an xy table, assuming that it's an equal sign. So when x is 0, y is 1. When x is 1, y is 0. So we'll plot those 2 points. 0, 1 is right here. 1, 0 is right here. So we want to draw a line through that. And it's a, these are all greater than or equal to. So these are all going to be solid lines. And I'm just going to put one right by this line so I know which equation that is. So now let's look at equation 2. We have a do XY table. So when x is 0, y is 1. And when x is, let's say, a negative 1, then we have y is 0. So negative 1, 0, and I'll do this in red. Negative 1, 0 is right here, and 0, 1 is right here. So again, we're going to draw a straight line through those. And we're going to call this equation 2. And equation 3 we'll do in, let's say purple. Y is greater than or equal to 2. So here's our line, equation 3. And so the area that we're going to shade is the area that's bounded by all three. And it's going to be this area here. So now the last thing we need to do is label the vertices. So this one here is negative 1, 2. This vertex is 0, 1. And this one here is 1, 2. Okay, that's it for this problem. Now we can have all kinds of different problems where we may have, for example, say we have a line and then we have a parabola. And so the area that we'd be interested in is this area here that's bounded between the two curves. Incidentally, we can find this area pretty easily using calculus, so that's a next year problem. We can also have a bunch of linear lines, say like this and maybe like this. And so here's 5 linear lines. I don't like the looks of this one, so I'm going to redo that one, let's say. Like that. Okay, and so then the area that we'd be looking at solving for is this area that's bounded by all three of them. We could also have a couple of conditions, say like we had 2 parallel lines, and we could have a no solution problem if the area, the shaded area, was outside here. So this would be no solution. And we could also have, say if we had a coordinate system that looked like this, and say we had one line that was going like this, say another line like this, and the area between the lines is going to be something like this. And so what we have on the right-hand side is an unbounded condition. So that would have if we didn't give it any intervals, it would be an infinite amount of area, so it would be an unbounded solution set. Okay, now we're going to look at consumer surplus and producer surplus. And we're going to draw a supply line and a demand line, or demand curve. So if you have an item that you're going to be selling, if the price is high enough, you're not going to sell any units. And so a demand curve looks something kind of like this, where the lower the price, the greater the number of units sold. But on the other side, on the supply side, this is the demand. But on the supply side, there's a certain point that is the minimum amount you're willing to supply it for. And so that curve, supply curve, is going to be something like this. So the higher the price, the more the units that you're willing to sell. And where they meet, so this is a supply. So where they meet is the equilibrium point. And if you draw a dashed line, it gives you the price where the demand curve equals the supply curve. We call that the equilibrium point, as the intersection. So the area above that, we're going to shade it in blue, and this is going to be called the consumer surplus. So this is the consumer surplus. And we're talking about the area. And in below the equilibrium line, we have this area shaded in red, and we're going to call that producer surplus. Okay, so let's do an example finding the consumer surplus and the producer surplus. Okay, here's an example. We're going to find consumer surplus and producer surplus. The demand equation is given as P is equal to 50 minus 0.04x. The supply equation is given as P is equal to 20 plus 0.01x. So what we want to do first is find the equilibrium point. So we set these two equations equal to each other. So we say 50 minus 0.04x is equal to 20 plus 0.01x. So subtract 20 from both sides, get 30. Add 0.04x to both sides, we get 0.05x. So x is equal to 30 divided by 0.05, which is 600. If we put that in either equation to solve for p, we use the bottom equation. P is 20 plus 0.01 times 600, so 20 plus 6. So P is equal to 26. So here is our equilibrium point. Let's go ahead and plot it. Well, let's go ahead and put some scales on the axis here. So we want to go out to 600 on the x. So let's call this 100, 200, 300, 400. 500, 600, and on the y-axis we want to go up to 50, 10, 20, 30, 40, 50. So now we can plot x equals 600 and 26, so value is going to be, here's your equilibrium point right about there. So now we can draw the curves. When x is 0 for the demand curve, 50 minus 0 is 50, so it's going to start at 50 and go through the equilibrium point. And then on the supply curve, supply equation, 20 plus 0 is 20, so start at 20 and it's going to go through the equilibrium point. And now we have to draw our dotted or dashed line at 26. So I'll just put the value 26 right there. And now we're ready to list our consumer surplus equations and the producer surplus equations. So we'll do the consumer surplus first. So the consumer series of equations are P is going to be less than or equal to, because we know it's lower than after we drew the curve. We know it's less than or equal to 50 minus 0.04x. That's the equation we were given. We also know that P is greater than or equal to 26. From the equilibrium point, we also know that x is greater than or equal to 0. So that's our consumer surplus. Now we'll do our producer surplus. And those equations are P P this time has to be greater than or equal to 20 plus 0.01x. We also know that P is less than or equal to 26, and x is greater than or equal to 0. So these are our three producer surplus equations. Last thing we need to do is find the area of the two. So I'm going to shade in first the consumer surplus. Then we need to find the area of this amount. Well, that's pretty easy enough to do. So the area is 1/2 base times the height. So 1/2, the base is 600, and the height is going to be 50 minus 26. So that works out to 50 minus 26 is 24. Half of 24 is 12. 12 times 600 is $7,200. Now what that means is that's the amount of dollars that consumers would be willing to pay above what they actually paid. So this is the consumer surplus. And next we have to find the producer surplus. So again, this is going to be the area that is shaded in red. And so same formula, this is a triangle. So the area of the producer surplus is 1/2 base times the height. So it's 1/2. The base again is 600. And the height is going to be 26 minus 20. So 26 minus 20, that's 6. Half of 6 is 3. 3 times 600, that is going to be $1,800. And that's the producer surplus. And in words, the producer surplus is the amount of dollars that producers would accept below what they actually received. So this is a producer. I didn't spell that right. There we go, producer surplus. Okay, that is it for 7.5.